Hello, and welcome to our presentation on the Nexus, where we are connecting students to the industrial Internet of Things. We are based in Omaha, Nebraska at Metropolitan Community College, and this grant was funded through the NSF. My name is Mike Gerke. I am the lead instructor on this project. Our key members have been Karen Wagner, who is our instructional designer who helped create all of the curriculum and ensure that all of the standards are fully up to date with the various high school standards around the nation. Lindsay Gibbs, who is our project director, and Critical Labs, who is our corporate partner. They are also the ones who have supplied the virtual sensors, which we will be talking about today. So, as everyone else has experienced over the last year, we had to switch from a very hands-on training scenario, getting equipment into students' hands, to a more virtual training scenario, where students can still get all of the same benefits from our curriculum. However, we want to ensure that they are safe in this COVID-19 pandemic world. Our grant deliverables were the curriculum, where we are trying to teach students the basics of lean production, just-in-time inventory management, project predictive maintenance, and rapid prototyping. We've broken that up into 4 different modules, which we have the students work on. During the pandemic, we realized we would no longer be able to supply the need for in-person training on these modules. So we have developed asynchronous training, which worked for a while. And now we have gone fully virtual with a couple virtual trainings in the first 3 modules. We have also created and supply instructional resources such as lesson plans, aligning all the standards to the high school standards around the nation. We have videos, assessments. All of this is located on our Canvas LMS site, where we have specific sites geared to both instructors as well as students. We have equipment kits, because that's what the first part of the grant was about, where we have sensors, software, and equipment lists with that. We also provide implementation support. So we had train the trainer, exploratory workshops, websites, and so on. However, with the pandemic, we have had to completely switch, and we are not having train the trainers and exploratory workshops at the moment. That has changed over the last couple of weeks, where we are allowed to have more students back in person. We have developed, however, a complete virtual site for all of our curriculum. So a quick background on what the industrial Internet of Things are. It's devices and sensors used mainly in critical facilities. We have students monitor data and make predictions in order to drive smart decision-making of these various scenarios that we have created. Data sent to the cloud and back to a central monitoring station. Even with the virtual sensors, most of that is still happening. All right, our grant equipment, which we still offer, includes a gateway, various temperature sensors, shock sensors, and contact sensors. All of the power supplies, Ethernet cables, and so on are also provided for students if they wish to take this sort of curriculum asynchronously or remotely. The only issue that we have that has come up when we started asynchronous sort of stuff is that we assume students would still be learning in the classroom somewhere remotely, where they would have access to power over Ethernet. What happened in reality was that students were working from home with a variety of devices, and so they could not power the gateways, and we couldn't get all of that set up. So we have developed then virtual scenarios. So with the COVID-19, we couldn't meet in person. That was both state and college mandated. How are we going to distribute this? We started asynchronously via Zoom, but can't get power over Ethernet at home unless I had students hack into their routers, and we didn't think that was very appropriate. So we have developed the simulations. The curriculum had to be completely redeveloped for a new audience, because at first it was developed solely for the instructors, and now we want to ensure that the students can do this curriculum. without instructor help. We know that instructors' times are stretched extremely thin now. So we need to ensure that this curriculum can be distributed as efficiently as possible. Our simulations include the 3 different modules to begin with. So we can have 4 simultaneous users. These are all password protected outside of module 3. So where we first had the order module 1, module 2, module 3, and we wanted the students kind of to complete them in order. With the new simulations, we are now introducing students to module 3 because we could have unlimited simultaneous users on module 3. Then we can get the students involved into the different temperature sensors for 1 and the different vibration sensors for 2. Since these are virtual sensors, we're still sending the data to the cloud through critical labs where they will display the data and be able to follow up with the rest of their worksheets and data collection. Our modules are the same, so we still have predictive maintenance where we are having students using temperature. They explore the dashboard and calculations. Lean manufacturing, where students monitor vibration and determine correlations to mass placement on a fan. That has changed on the virtual sensor because now we can simulate an actual failure of equipment where students then will monitor the data to determine when the fan has failed. We finally have just-in-time inventory where the students were originally using the contact switch to monitor product being produced. And this module has actually become much more realistic with the game simulation that we have had created. All right, our first module was predictive maintenance. You'll see here what happens in real life. Students have a hair dryer, they're shooting it at our temperature sensor, they're monitoring how the temperature is changed via the setting of the hair dryer and how far the hair dryer is away from the sensor. We have experiments, and this is where the students are introduced to the dashboard and the different widgets that they can create on the Critical Labs website. We are trying to assess here how they calculate data and how they work in a team. The data is collected in degrees C. We have them convert that to Fahrenheit, where we can show basic mathematics skills as well as other things. On our simulation, you'll see that it's quite similar. We still have a hair dryer attached. It's shooting down towards a sensor. You can change the settings of the hair dryer with the buttons on the left, as well as raise and lower the table height. This infographic shows that the data is transferring from the sensor through the gateway at the bottom right, up through the cloud to the Critical Labs dashboard. This is very true to the original experiment, as you saw before. It's just a little more cartoonized, little more cartoony, which allows students to better visualize what is happening. The data is still 100% processed in the Critical Lab servers. All of the dashboard skills, which they learned in person, would not have changed when it comes to this simulation. As for the dashboard, you'll see students will get a series of raw data, which they can then create a widget to calculate the data out. Here we have created a simple calculator that displays the data from the raw data coming in as Celsius to Fahrenheit. In our second module for lean manufacturing, students are introduced to the different sensor types. This is where we go through all the various sensors where students might encounter in their day-to-day lives, especially working in one of these critical facilities. They're going to be tasked with monitoring weight distribution on a fan in this physical scenario. They'll create a dashboard from scratch on the Critical Labs database. We use the weights on the fan in this distribution in order for the students to see how vibrations can increase over time, leading to failure of equipment. Now, we couldn't randomly get a fan to fail in real life. However, with our module, we weren't limited to that problem. So we pivoted slightly, where you'll see on the bottom, we can monitor a fan at its normal operation and monitor the vibration that's outputted from the fan. And then we have a button to have the fan go into a random failure mode. This random failure mode might happen within the first 30 seconds. It might take a couple minutes. Students are to hit that button after they've created a dashboard to understand what they're looking for. And then they will monitor the data on the dashboard to determine when the fan has failed. This is more akin to the real world scenario, since you're not trying to break your fans in the real world. Rather, you're just monitoring data to see if there's any deviation in what normal operation should be. Our third module was just-in-time inventory. This was our final scripted module, where we say scripted, where we know what the main solution is probably going to be. The students are challenged to a full range of knowledge in this module, and this one was the closest scenario to reality. Students were to monitor product being removed using magnetic dominoes on a contact switch and try to assume when they should resupply their robots and when they should ship their finished product. Now, this in-person scenario was complicated and was confusing for the students, who required a good amount of knowledge and some patience in order to get right. The simulation, however, has taken that and turned on its head. This is where the simulation really has pushed past anything that we could have done in person. We have gamified the scenario where students have buttons where they're going to start ordering plastic and preparing shipments. You'll see at the top here, their goal is to make sure that they're not overstoring plastic or running out of plastic, and make sure that they're sending shields out without losing too much money by shipping too often. This allows our students to really compete with one another as they're going back and forth. It gets them really excited to start going. And after that, we can start transferring back into the real world scenarios. Our final module has no answer to it. We want to have students come up with one of our available scenarios and come up with a solution to the manufacturer's problem. There is no right or wrong answer to this problem. They will design and build an IIoT solution using the loan technology where they can, as well as sketching out possible solutions and building dashboards. We want them to collect sample data and discuss furthering their tech understanding, for them to understand what's happening in this imaginary factory, which are all based on real world manufacturing facilities in Omaha, how they can improve workflow, keep people safer, keep the downtime to a minimum, and just use this technology to increase the efficiency of a manufacturing scenario. With the grant, we have, before COVID, purchased a bunch of equipment for a loaner library. This is still completely available. They're fully deployable kits where anyone around the country could request from us. We will send them out. We have 4 of them available. However, power over Ethernet is a necessity. They can be purchased as well if companies, colleges, individuals want to have their own kit where they can develop their own curriculum from. Our kit comes with a gateway, 12 sensors, power, Ethernet cables, and all of the curriculum that we saw before. It also allows people to sign up for times on our virtual sensors. Our website is located here. You can also use the phone number to contact us at any time or send us an email. Again, my name is Mike Gerke with Metropolitan Community College based in Omaha, Nebraska. This was a presentation on NEXUS and how we pivoted from hands-on to a more virtual training demand for our IIoT project. We are funded through NSF. Thank you.